Good morning, friends. Today we are going to discuss about what is the polarization and how we obtain the plane polarized light from the unpolarized light. In last lecture we discussed also about the unpolarized light and plane polarized light. Unpolarized light, that means the electric field vector oscillating in a plane perpendicular to the direction of propagation of a wave in all direction. So such light is known as the unpolarized light. That means the electric field vector is oscillating in all direction, perpendicular to the direction of propagation of a wave. Now, what is the polarized light? In polarized light, the electric field vector are coplanar and parallel to each other. Also oscillate in a plane. This plane is perpendicular to the direction of propagation of a wave. So in short, in unpolarized light, electric field vector in all direction perpendicular to the direction of propagation of a wave. While in polarized light, the electric field vector are only in any one direction. This direction is perpendicular to the direction of propagation of a wave. Now, what is the phenomena of polarization? The phenomena to obtain the plane polarized light from unpolarized light is known as the polarization. And the sheet or the plate by which plane polarized light is obtained from unpolarized light, that is known as the polaroid. The example of the polaroids are thin plastic sheet and also the natural crystal, that is the tourmaline plate. Okay, we return this thing. The phenomena to obtain plane polarized light from unpolarized light is known as polarization. Is known as polarization. A sheet or a plate by which polarized light is obtained from unpolarized light is known as polaroid. Polaroid. As an example of the polaroids are thin plastic sheet, and tourmaline plate. Tourmaline plate is the natural crystal which is act as a polaroid. Now, in a polaroid, the polaroid consists of a long chain of molecules aligned in a particular direction. Now, so what's happened? Due to the particular long chain of molecule aligned in a particular direction, what's happened? Like this way, There is the thin plastic sheet. Here the molecule of the plastic are arranged in long chain in a particular direction. That is a thin plastic sheet. Here the arrangement of the molecule are in this direction, horizontal direction. When the electric field vector oscillating along this direction like this way is enter or incident on this plastic sheet. So this electric field vector are absorbed by plastic sheet. While when the electric field vector oscillates perpendicular to the particular direction of element of the molecule, like this way, so it can easily pass through the thin plastic shell. So this direction of the sheet is known as pass axis, or that is known as the axis of the polarity. Axis of the polarity. For that purpose, here we enter like this way. If the electric field vector, that means the E vector oscillating along the direction of to the aligned molecule get absorbed, while oscillating in perpendicular direction to the aligned molecule passes through the sheet. This direction of the sheet, is known as axis of a polarity. Is known as axis, or that is also sometimes known as the pass axis of a solenoid. Pass axis of a polarity. So there is the information about the polarity and phenomena of polarization. Again, the phenomena to obtain the plane polarized light from the unpolarized light is known as the polarization. Now, a sheet or the plate by which the polarized light is obtained from the unpolarized light is known as the polarizer. Example of the polarizers are thin plastic sheet or tourmaline plate. Now, in polarizer is what? A polarizer consists of a long chain of molecules aligned in a particular direction. Now, if the electric field vector or the electric vector E oscillating along the direction of a line molecule of a sheet, that is get absorbed, while oscillating in perpendicular direction to the aligned molecules can pass through the sheet. This direction of a sheet is known as axis of a polarity. Now, the light from the ordinary source, as shown in the figure, here we describe or we first do the diagram like this manner. Suppose there is the axis here, the unpolarized light is this. This unpolarized light is coming from the ordinary source. Unpolarized light incident on a thin plastic sheet. Incident on a thin plastic sheet. So molecules are arranged or the aligned. Long chain of the molecule in thin plastic sheet are aligned horizontally. Therefore, the path axis is this. Axis of a polaroid. Axis of a polaroid. When this unpolarized light is incident on the polaroid P1, what's happened? On the other side of the light coming from this is parallel to the path axis. Parallel to the path axis. And this light is the plane polarized light. There is the plane polarized light. So that is a figure A. We describe this thing. Now, what's happened? The light from the ordinary source is incident on a polaroid P1. The intensity of the light transmitted from the P1 becomes the half of the incident light. If the light from ordinary source incident on a polaroid P1. The intensity of the light transmitted from P1 is half of intensity of incident light. Now, rotating on rotating P1 about axis, there is no change in intensity of transmitted light. There is no change in intensity of transmitted light. That means as we place the polaroid P1, that means the unpolarized light is incident on a polaroid P1. So what's happened? What are the electric field vector oscillating parallel to the axis of a polaroid can easily pass, while the other are absorbed like this way. these are oscillating, this oscillating, now this oscillating, are absorbed by the polaroid or the thin sheet of a plastic. Only what are the parallel to the axis are passes through the polaroid. But what's happened? The intensity of the plain polarized light becomes the half of unpolarized light. That means the incident light on a polaroid. Now, as we rotate this sheet this way, there is no difference in the intensity of the transmitted light. So, intensity of the transmitted light is remain constant. Now, what's happened? As we place the another identical polaroid before the P1. So what's happened? We discuss here. Okay, now what's happened? Just we discussed about that the ordinary light from the ordinary source is incident on a polaroid or thin plastic sheet. What are the electric field vector oscillating parallel to the axis of a polaroid can easily pass, while what are the electric field vector not oscillating aligned in the direction of the sheet are absorbed by the sheet. Now what's happened? Yes, we introduced the another identical sheet P2 before the P1. Here the unpolarized light, here the one more sheet P2 we introduced, here the P1. So what's happened on other side was the light coming from the P1. So the intensity of the light emerging from the last sheet P1 depends on the relative position between the two plates. Relative position between two plates. When the both plates are parallel, P2, there is the P2, there is the P1. At that time what's happened? The axis, path axis of the both sheets are also parallel to each other. Therefore, electric field vector oscillating parallel to the axis easily pass from the P2 and also easily pass from the P1, while the intensity of the light is same as the transmitted light of P2. What are the intensity here? The same intensity we obtain after the P1. And if the P1 is now rotated with respect to the P2, so when the both sheets are perpendicular to each other, the intensity of the transmitted light is reduced to 0. We are going to discuss this thing. So here, according to this, we do the diagram like that way. Now there is the unpolarized light. So electric field vector oscillating in all directions. There is the sheet P1. The axis of the sheet P2, sorry. There is the P2. There is polarizer. Now the another sheet we placed parallel to that. Axis is also same, parallel, P1. P1 is the analyzer. So here there is the plane polarized light. This plane polarized light is incident on the other sheet P1. The transmitted light from the P1 is also the same. Therefore, the intensity of the light emerging from the P1 is same as the intensity of the light emerging from P2. So when P2 and P1 are parallel to each other, the light vector passes through P1 passes through P2 also passes through P1, also passes through P1. Thus, the intensity of transmitted light from P1 is equal to the light transmitted from P1. Light transmitted from P2. That means the intensity of this light and this light are same. On rotating the P1, about its axis, on rotating the P1 about its axis by 90 degree, the intensity of light transmitted by, or the transmitted from P1 reduced to zero. That means here we do the diagram. There is the axis. Here the P2 is kept as it is. But the P1 is perpendicular to the P2. That is the P2. Now, there is P1. P1 is rotated by the 90 degree. That is its axis. So what's happened here? In this side, the light are plane polarized. That is incident on the P1. So here, the electric field vector oscillating perpendicular to the axis of P1. Therefore, no light is obtained. Thus, so conclusion is that thus the light passes through the P2 and P1 by keeping the P2 is fixed and rotating the P1 from 0 to 90 degree. The intensity of the transmitted light from the P1 is changes from 1 to 0, the I to 0. Thus, if P2 is kept in same position and P1 is rotating from 0 to 90 degree, the intensity of the light transmitted by P1 is changes from I to 0. There is depends on the angle between the axis of P2 and P1. Here is so there is the process of polarization. How we obtain the plane polarized light by the single polaroid or the double polaroid. As we rotate the single polaroid only, so intensity of the transmitted light is not affected because as forget the P1, only the P2. So each and every position, any electric field vector oscillate parallel to the axis of a polaroid. Therefore, any position of the polaroid, we obtain the plane polarized light. But when we are using or we kept the two sheet or the two polaroid and we rotate or the relative motion of these two polaroid take place, that means the one is kept fixed, second is rotating. So when the axis of the both polaroid becomes the parallel, in that case only we obtain the maximum intensity of the transmitted light, but the intensity of the transmitted light is half of the intensity of the unpolarized light. And due to the rotation of P1, what's happened? The intensity of transmitted light is changes from I to maximum to minimum, that means the I to 0. Now next question is explain the Malus law and define it. For that purpose here, the unpolarized light, that is the unpolarized light, incident on a first sheet, that means the plate P2, that is our polarizer. So as a result, that means the light emerging out from the polarizer is plane polarized light. That is the plane polarized light. And next, there is incident on the another sheet P1. Another sheet P1 is our analyzer. That is the analyzer. Now the axis of the P2 makes an angle theta with the axis of P1. Axis of P1. Therefore, whatever the light, plane polarized light coming from the plate P2 is incident on the axis of a polarized analyzer at angle theta. Therefore, we consider the two components of electric field vector E0. One is the E0 cos theta parallel to the axis of analyzer P1 and E0 sin theta. E0 sin theta is what? That is the perpendicular to the axis of P1. Right, what's happened here? The E0 sin theta component is absorbed by the sheet P1 and the emerging light is, it means the transmitted light from the P1 is the E0 cos theta 0 or the E0 cos theta. The intensity is E0 cos theta. There is the final transmitted light from the analyzer of the other sheet P1. For that purpose, we have done like that if the axis of sheet P2 makes an angle theta with axis of sheet P1. Axis of sheet the polarized light or the plane polarized light from P2 is incident on axis of P1 at an angle therefore consider two components of light vector E0 first is E0 cos theta parallel to the axis of P1 and second component is E0 sin theta. E0 sin theta perpendicular to the axis of a perpendicular to the axis of P1. Axis of here what's happened? E0 cos theta component which is parallel to the axis of a plate P1 pass through the P1 while the E0 sin theta component is absorbed. Here E0 cos theta component is passes through P1 while E0 sin theta component is absorbed by P1. Now the intensity of the light incident on the P2 is directly proportional to the square of amplitude of light, incident light. The intensity of incident light is proportional to the square of amplitude of incident light. Therefore, I0 proportional to the E0 square. And intensity of transmitted light from P1 is proportional to square of E0 cos theta. Therefore, I proportional to the E0 cos theta whole square. That is equation number 2. Therefore, intensity of transmitted light is I upon I0 is equal to E0 square upon E0 square cos square theta. E0 square cancel. Therefore, I is proportional to the E0 square cos square theta upon E0 square. That is cancelled. Therefore, I is equal to I0 cos square theta. This is Malus law. This is Malus law. So that is the Malus law. Yeah, actually we have to explain the polarization and we have to discuss about what's happened if the angle between the axis of the both polarity or the both sheet P2 and P1 is theta. So what is the intensity of the final emerging light? Final emerging light I is equal to I0 cos square theta. Here theta is the angle between the axis of two polarity. Okay, so that is the Malus law.